Hi there. In this video, we're learning how to rebuild packages using the Guix build command. We use Guix build to build any package, so whether that's an old package or a new package that we're adding. In this case, we're going to use it to build packages that Guix already knows about. That's packages that are within the Guix archive. So we can actually rebuild any package that Guix has already. Guix build is used to build a package. Technically, it builds a derivation, and what we're generally interested in is the package. Guix build receives a package definition and some build options. It outputs a build log and then a build derivation, and often the one that we're interested in is the package output. I recommend that you use Guix shell to create a clean build environment that's completely separated from your normal environment. To build a package, there's basically 3 steps. We need to create a build environment using Guix shell. Then we need to build the package itself. Now, in the case where you're building a package that's already within the archive, it's going to use all of the definitions from the archive, including other inputs, so other dependencies that are needed in order to build that package. It's going to download and install those using the definition that's within the Guix archive. And then the third step is to create a test environment, again using Guix shell, and then to test the new build. So to start our build environment, we use the Guix shell command. In this case, I'm going to use Guix shell with the container, nesting, and a network switches. So that's going to create a fully separated environment, a container. Because I want to run other Guix commands within that environment, I'm using nesting. And because I need to download the source of the package, I need access to the network. So that's why the network switch is there. In this case, I'm building the hello package. So that's why I provide development hello. That's going to install any libraries that are needed in order to build the hello package, along with any build tools that are needed. I also ask it to install the NSS certs package, and that's so that Guix can download sources over HTTPS. Here we are in our Guix shell, which is our build environment. And the first thing that we're going to do is use the source switch. And so what the source switch does is it downloads the source of the package, which is within the package definition, the recipe, and it puts it into the store. So in this case, we can see that it's downloaded the package for hello, the tar.gz, and it's put it into the store, and that's the location with /gnu/store, the directory. The next thing we're going to do is provide the dry run switch. And the dry run switch tells us what Guix build would do if we ask it to build the hello package. And in this case, it tells us that it would download the package. And that's because by default, it would download and install the binary substitute rather than building it. That's normally the most efficient method so that we get the package as quickly as possible, and it avoids everyone wasting time building resources or using resources to build packages. But in this case, we want to show how to build packages. So to do that, we tell it that it should not use the substitute servers with the no substitute switch. So when you run that, it tells us that the following derivation would be built. And finally, I'm going to use the no grafts option. So we're going to build the package now, and I'll tell you a little bit about grafts. So grafts are a really interesting capability, and they help us with security. Essentially, we can graft an updated package, so one with an added security patch, onto a package lower down in the dependency tree. And this avoids having to rebuild every package in the store, as normally if we updated a package lower down in the dependency tree, we would then have to rebuild every single package that depended on it. But by using a graft, we can graft that updated package onto the dependency tree. So it's a really efficient way for us to get security updates without having to rebuild everything. Due to the way that grafts are applied, this happens at the end of the build, and so it can slow down builds if there are a lot of grafts. And it's completely appropriate to use no graphs if you're building development versions of packages, but obviously for a final build, if you were contributing that package or updating a package within Guix itself, you'd use graphs to make sure that all security patches were applied and your build still worked. Alright, so it's completed that build, and as we can see, there are two outputs. The first is the derivation, and so we could check that to see some of the details of the build, but we're not going to dive into derivations today. And the second is the package itself, and so that's that GNU store directory. One thing we do want to check is that a build is reproducible, and we can check that by using the check switch. So here's the command, and this time we're using the check command. And what this is going to do is it's going to actually rebuild the package itself. So it's going to create a new build of the package, and then it's going to compare it to our existing build of the package and check that the two come out the same. And as we know, the way that Guix works is it has a hash of the package, and that's and the name of the package, and it uses that hash to create the location with the name in the store. So that's why we get /GNU/store, a long hash, and then the name of the package itself. So it can check that the two packages have come out at exactly the same by checking that the hash location is the same. So if the hash and the final location are the same, we know that the package has reproducibly built. All right, and now we can see here that the /GNU/store has that long hash that was taken during the build process and then used for the final store location, and the name of the package itself, hello in this case, and both of those are showing to be exactly the same each time, so we know that this build is reproducible. So the final step is that we want to move on to testing our package by installing it, and we install it with the long hash. And in this case, we're then going to run the package directly, and there we go. Hello world, so it works. We've been able to install it and test it. Now when you're test building packages, you'll often want to repeatedly build them or do sort of small variations to them and build the new variation and so forth. So it's quite common that you want to remove the package from the store, or maybe you want to remove the source from the store and start the whole process right from the beginning to check that everything works. And in order to do that, we use the gc command and the path to the package itself. So again, we're using that long GNU store location where the package is, and we're using Guix gc and then the delete option to delete the package. And we can see here that it finds the garbage collection routes and then removes the package and anything else where it was used. Now, one of the benefits of using containers for the build environment is that the minute that you leave the container environment, you then won't have the package attached to a generation of your profile. If you built the package in your normal profile, then you'd have to remove the generation where you'd installed it and then remove the package itself. So it's an extra step. And that's one of the things I like about using Guix Shell. The minute that we leave the environment, we can then just simply remove the package from the shell. All right, let's quickly recap then what we just saw. So the most common build options that we would use are the dry run, no substitutes, and no graphs, and we just showed how to use those. We can also use the verbosity option to decide how much output we're going to see from the build. In some cases, it's useful to control how many cores the actual build is using, so how much resources from your computer it's using. One thing to bear in mind here is the way this works is that the Guix daemon allows a certain number of jobs. So that's the max jobs option there. And for each one of those jobs, you set a number of cores. So if you decided to allow 3 jobs, and then each one was allowed 2 cores, you'd be using 6 cores in total. And so when you're thinking about how many resources to use or how much resources to use, that's the way to think about it. We used the check switch to check for build determinism, and then we used the source switch to download the package's source and build a source derivation. So we've used the most common Guix build options to build our packages, and in this case we've built a package from the archive. We used Guix shell to create our build and our test environment, and then we showed how to install the package locally into one of those shell's environments to test it. Having learnt the basic build command, what can you do from here? The next step is that you can use the transform command. So transformations allow us to build local variants of packages. We can do that either from the command line or in manifests, and then we can have transformations within those manifests to build our own local versions of packages. If you'd like to see some more examples of how to use the Guix build command, have a look at the blog that I've put into the show notes. Thanks very much.